Forrest Brazeal, warm welcome, and let's start our second presentation.
All right, well, good morning. It's great to be here in Kyiv. As we get started today, I want to ask you to imagine with me your worst IT nightmare. All right, imagine this. Imagine you have a project maybe that goes massively over budget. You have a project that gets hacked in some way and gets exposed on the internet. Imagine perhaps even that you have something that is completely takes your services down at a critical time for your business. All these are terrible things that we can imagine. Whatever you're thinking of right now, whatever your nightmare scenario is for your business, it's probably not as bad as what happened in 2016 to the Australian government. All right, now just to clarify, I'm not Australian, I don't work for the Australian government. Everything I'm about to tell you is public information. I read about it in the news. So that should tell you right away just how bad this is about to get. All right, so the Australian Bureau of Statistics, one of the things that they do every 5 years is they do the census for the whole country of Australia. And in 2016, they decided that for the first time they were going to do this census primarily online. That meant that on a given day, everybody in the country was going to log onto a web portal, they were going to fill out their census information, and they were going to click submit. Well, as you can imagine, the Australian government was very concerned about making sure that this system worked right. Because you can get fined if you don't fill out that census on time, so everybody had to be able to log on and access the system. They spent hundreds of thousands of dollars load testing this system. They said they could handle up to 1 million form submissions every hour. And then they put the census online, everybody got online at the same time to fill it out, and what do you think happened? They immediately started having problems. People couldn't access it. There were some denial of service attacks that started coming in from outside the country, and after only a couple of hours, they were forced to put the thing on Twitter that you never want to have to put on Twitter. Currently experiencing an outage. Oh no, we're going to have to wait and get this restored. Well, how long do you think it took them to get the website back online? 1 hour? 2 hours? More than 24 hours. They were completely down. Nobody in the country could fill out their census forms. People were panicking. The hashtag quickly spread on social media, census fail. Oh no. All right, well, when the dust settled from this a little bit, it quickly became clear that they had gone more than $24 million over budget trying to get this system that never actually worked online. The data eventually came out, but people were saying, well, maybe this census data should just be scrapped. You know, we can't trust it, right? We don't know if everyone was eventually able to get online. We don't know if the system was hacked. Essentially, trust in the system had been destroyed, a nightmare scenario for the Australian Census Bureau. You might think that story can't get any worse, but it actually did. Only a few days after this whole debacle went down, news got out about a couple of college students, that's right, university students at the Queensland Institute of Technology right there in Australia, and they claimed that they had built a better version of the census website. They called it Make Census Great Again, and they had built it in only 48 hours at a weekend hackathon. They claimed they had done this using serverless technology, which in this case meant they had used some stuff from Amazon Web Services like AWS Lambda and DynamoDB. All right, they had put this together over the course of a weekend, and they claimed that it fulfilled the basic requirements of the census website at more than 40 times the load that the actual census website completely failed to handle. Well, that's about the most embarrassing thing of all. We're going to come back to this story a little later because I think it's going to inform a lot of what we're talking about. But let me introduce myself real quick as we get started. My name is Forrest Brazeal. I'm an American. I work for an American company called Trek 10. I'm a cloud architect there. We're an Amazon Web Services consulting partner, so that means we spend a lot of time helping clients build things in the cloud. In particular, I like to focus on serverless. I'm what's called an AWS serverless hero, which basically just means I spend a lot of my time helping to educate the broader community about this technology. And you may know my name if you've ever used a site called A Cloud Guru. Anybody heard of A Cloud Guru? Yeah, several people have. It's a cloud training site. I write for their community publication, and I also draw cartoons for them. So there may or may not be some cartoons coming up later in this talk to help us understand what we're going to be dealing with. So today we're going to be talking about the case for serverless in the enterprise. We're going to be looking at how you can use those serverless technologies that the Australian students use to hopefully avoid a debacle like we saw in our opening story. Now, who thinks they can define the word serverless? Who thinks you could give a clear explanation of what that means? I see like 2 hands, all right? It's confusing, right? It's kind of a buzzword. There's a lot of conflicting information out there. So I think we'd better get started by all getting on the same page about what serverless is. And to do that, we have to go back a little bit to the beginning. Anybody have a network closet that looks something like this? Or ever worked with something like this? Yeah, all those terrible tangled wires, those servers sitting in your closet. Fortunately, we've started to move away from this a little bit over the last few years because the trend in computing has been toward abstraction. We've gone from those physical bare metal machines to virtualization, where at least we had the ability to have some layer of abstraction on top of those servers. From there, we went to hosting, to cloud computing, where we still have virtual machines, but instead of running them ourselves, we're going to run them on, a cloud provider's data center. And from there, a big topic in the last few years has been containers. So we don't even have the virtual machines anymore, right? We take our application and our dependencies and we go one level of abstraction higher. And then finally, what we're going to be talking about today is serverless. And in the serverless world, you just have your code and everything below that layer is handled for you by a cloud provider. Given what I've just said, you may have realized that serverless is kind of a bad name, right? I get it. There are still servers in serverless, okay? You go far enough down that abstraction layer and you're going to find a server somewhere. But the term really describes the abstraction. So if I'm a developer and I don't have to care about servers, I don't have to maintain them, don't have to provision them, don't have to patch them at 3 in the morning, then for all I'm concerned, there may be some magic layer of unicorns and rainbows that's serving my code. That's kind of what we mean when we use the term serverless. And I think people struggle to get their heads around what this means. So when I explain it to people, I try to talk about serverless as being the union of 2 things, an operational model and a programming model. The serverless programming model is not just serverless, it is very much serviceful. By that I mean you want to try and use managed services whenever you possibly can. I'll give you an example. Have you ever had to code up like a login flow for your website, a login portal, forgot password link, verify email flow, all of that? You could write all of that yourself, just like the last 10,000 people that had to write that. Or you could use an existing service like Auth0 or Amazon Cognito and spend your time building code that's actually directly useful to your business. That would be a serviceful approach by using that service. We talk about the programming model being event-driven, being stateless. That just means instead of having a server that's running all the time, instead you want to try and just have code that runs in response to events. So when something actually happens, you'll spin up a little bit of compute in order to handle it. That's the programming model. The other half of it, again, is the operational model. This is where we talk about serverless being fully managed. Hopefully with serverless, you're not having to provision infrastructure yourself. As I mentioned, not having to get up at 3 in the morning and patch your servers, worry about the zero-day security vulnerabilities at the infrastructure layer. That should all be taken care of for you by the cloud provider. We also talk, again, about it being usage priced. This is a really important concept that I want to make sure we understand because a lot of cloud services are what you call pay-as-you-go. Anybody used Amazon EC2, the virtual machines? Yeah, quite a few people have. So EC2 is billed by the seconds now. You get paid, or you get charged specifically for the number of seconds that compute runs. But have you ever turned on an EC2 instance, like to test something, and then forgot about it and didn't remember till you got the bill a month later? Yeah, some people have done that. That's because it's not a usage price service. You're going to get charged whether or not you're actually using that server as long as it's turned on. Serverless is very different. If you create like an AWS Lambda function and you put it up on the cloud, you're going to get charged exactly nothing until somebody actually calls that code and it runs in response to that event. That's what we mean by usage priced. Now, you could have a service that fulfills maybe part of the operational model of service or part of the programming model, but the sweet spot where you're going to get all the benefits of what we're going to talk about today is right there in the middle of those 2 things. And I understand this can be a hard concept to grasp. So we're going to play a quick game now that I like to call, Is It Serverless? So I'm going to show you an example of a few different services. You tell me whether or not you think they're serverless based on the definition that we just put together. All right, AWS Lambda, what do you think? Serverless or not? Who says serverless? Yes, okay, everybody gets this one. This is like the classic serverless service. It's a functions as a service thing that lets you run stateless code in response to events, usage price, fully managed, everything we just talked about. All right, next one is kubeless. You may not know what this is, but who's heard of Kubernetes? Yeah, it's a container service. So kubeless lets you run functions on top of a Kubernetes cluster. So it's like Lambda on top of a Kubernetes cluster. Who says this would be serverless? Not as many people willing to commit. Some people say it is. So this is definitely the serverless programming model, right? It's event-driven, it's stateless, but it's not the operational model because it's not going to be fully managed. You still are responsible for maintaining that cluster, the Kubernetes cluster, and potentially even the infrastructure underneath it. So I would say this does not fall right in that sweet spot of serverless. Next one. If you can see that down below, AWS RDS Postgres. This would be Amazon's managed relational database service. Who says serverless? So people say serverless. Definitely fully managed for you, right? You can't log into that server and patch the underlying operating system. You can't even patch the database. All managed for you by Amazon. But it's not usage priced. If you stand up an RDS instance, you're going to get charged for it as long as it's running, whether or not you're actually using it. So again, doesn't quite fulfill serverless. All right. Literally a server. What do you think? Is it serverless? No, okay, just making sure you're paying attention. That is definitely not serverless. All right, so deep breath. We just spent some time talking about what serverless is. Now we get to the most important and fundamental question of all, which is, who cares? All right, we've talked about a lot of buzzwords. Ultimately, these are all just different kinds of technology. They're great at doing different kinds of things. If you're going to use serverless in your environment, in your enterprise, you need to be convinced that it actually makes sense and actually helps your business. So let's talk about some ways that it might. We're going to kind of look at the economic model a little bit, and we're going to talk first about infrastructure costs. I know that sounds kind of boring, but stick with me. I was talking recently to Tim Wagner, who until just a few weeks ago was the general manager of all things serverless at Amazon, and he was telling me that most enterprise servers that he sees are just 10 to 15% utilized. To put it the other way, that means 80 to 85% of the time, the average server is just sitting there doing nothing. All right, now this is not an isolated issue. When you run your own servers, by definition, you often wind up either being over-provisioned, meaning that, again, they're sitting there doing nothing, or overutilized, where you've rapidly filled up your server capacity, and now you have to auto-scale, add more servers, but you're adding that compute at the level of an entire server, so right away, you know you're not going to be using all that compute, and you lose even more money. This is just a problem in the cloud because we are paying as we go, and every piece of compute that we're not using, we're paying for. So kind of the question and the dream of serverless is, what if we could always run exactly as much compute as we need, no more, and certainly no less? Hope you can read this graph. This was actually drawn originally on a whiteboard, but it's been so useful to our clients at Trek 10 that I'm including it here sort of for nostalgia's sake. That red line up the middle, that's how the cost of a serverless system should increase with scale. And you'll notice that it's kind of linear, because the more invocations that you make to that code, the more serverless function invocations should spread out, and theoretically that cost increases linearly. Now the blue lines, that's what you would pay if you had a traditional system, like using EC2 virtual machines. And you'll notice that you provision a server, and right away, it's not using very much of its capacity. Over time, theoretically, that system increases in capacity, and slowly, you fill up the server until all of a sudden, you have to auto-scale, and you jump up in kind of a stair-step pattern, and now you slowly fill up again. And that green space, those green hash marks in between there, that's what you're wasting on a traditional system, or to put it in a more positive way, that's what you'd be saving in a serverless model. A company that's doing really well of this, I mentioned briefly in my introduction, A Cloud Guru. They like to call themselves the world's first truly serverless startup. And what they mean by that is that when they got going 3-4 years ago, they actually built directly on top of serverless technologies for their video streaming, for their course lessons, and their website, everything, right as that technology was first coming into its own. They actually ran completely free on AWS Lambda for more than a year. You get something like 1 million free requests on Lambda per month. It's pretty insane. Of course, they're much too big for that now. They train more than 600,000 cloud engineers, and to do that, they're running, at last count, about 6.5 million Lambda invocations per day. Not per month, not per year, per day. And to do that, they are getting charged slightly less than $600 per month. I think that's like 16,000 hryvnia, if I remember my Ukrainian conversions correctly. Hope I got that right. You can criticize me later if I didn't. So that's about the cost of one pretty beefy EC2 server to handle all of that. And that would be if you were just naively comparing EC2 cost to Lambda cost. but it would be a little naive to do that because you're getting a lot of other things in that functions as a service price. Think about you're getting at no extra charge with Lambda. You're getting queuing, right? Because those invocations have to be processed by the platform and farmed out to function invocations. You're getting load balancing, a certain amount of high availability within a region. You're getting some auto-scaling. And I don't want you to miss this. You actually have an HTTP API that's made available to you. By that I mean, when you make a function invocation, you don't have to go through a separate service like Amazon's API gateway. You can, but if you control the client, you can actually invoke Lambda directly. And there's no extra charge for that. This is all rolled into that already low price that we saw with functions as a service. Right about here is where people tend to bring up what I refer to as the pizza question. This is where they say, you know, the whole serverless thing reminds me of the idea of buying a pizza. If I bought a single slice of pizza, that would cost me less money than if I bought an entire pizza. But there's a markup on each individual piece of pizza. So if I bought like 8 pieces of pizza individually, that would cost me quite a bit more than just buying an entire pizza up front. Isn't that what serverless is? If I buy enough function invocations, wouldn't it actually save me money if I just went ahead and bought an entire server or rented a virtual machine on Amazon? And in one respect, that's true. Yes, you will hit a point of scale beyond which there is a markup on those individual function invocations that will mean it's more expensive than a raw EC2 instance. But infrastructure costs are really just the tip of the iceberg you have to think about when you look at the economics of serverless. I warned you there might be some cartoons in this talk, and I actually drew a cartoon to help illustrate what I mean by this. So here's what I drew. There's 2 icebergs in this picture. The iceberg on the left is serverless costs, and you'll notice that there's a little bit more of that that's poking out of the water. That's because when you use any managed service, yes, there's going to be potentially a little bit more cost up front. But there's a lot more below the waterline on that other iceberg. I was talking to a friend recently who was looking for a logging solution for a startup that he has. So he said, you know, I could use like Splunk or Sumo Logic, a managed service for this, and he had done the math on the amount of logs he had, and he had figured out that it was going to be, I don't know, like $10,000 a year for him to do this logging that way. He said, on the other hand, I could go with something like Elasticstack, right? Open source project. I could host it on EC2 in my own Amazon account, and that would cost me $5,000 or $6,000 a year. So, seems like a clear savings to roll his own. But what I said to him was, how much of your engineer's time is going to be spent standing up that standalone solution? And he said, well, maybe a couple months. You think, at least, you know, and even after they figure out how to do that and get that all stood up, it's not going to be as good as what Splunk or Sumo Logic has, because those engineers, that's their domain. They do that all day and work with many, many customers, whereas you're just kind of trying to do this homegrown thing that you don't have the expertise on. And of course, once you create it, now you're going to have all of the maintenance responsibilities that go with it. So it's not just a couple months to build the thing, it's the increasing cost over time to log in at 3 in the morning and patch those servers, to maintain all those scripts that you had to write, to deploy and manage this stuff. So the overarching technical debt continues to accumulate. And here's the biggest thing that I don't want you to miss. There's an innovation cost, an opportunity cost here. What could your engineers have been doing other than building a logging system in that time? What could they have been building that's directly useful for your customers? All right? The logging stack is not something that your customers directly consume. Your engineers are the only people in the world who know how to build what you build uniquely. They should be spending their time building that. So I've summarized some of these things here, these hidden costs, the infrastructure maintenance, the technical debt, the time to market. And all of these are just additional costs that you don't necessarily see when you look at the pure sticker price of serverless, but they are things that are just being abstracted away from you. This is where people tend to bring up the question, what about lock-in? Vendor lock-in. Kind of a scary word that people worry about anytime you have a managed service. They say, well, I get it. I may save some money by not building all this myself. But what about after I've been using this cloud provider for a few months or a few years, and then all of a sudden they decide to raise their prices? Well, I had built all of my infrastructure on top of their compute. I'm stuck. There's nowhere I can go. I am locked in. I couldn't move if I wanted to. Or worse, what if the cloud provider just happens to deprecate a service that I rely on? Again, I'm locked in. These are the concerns people have, and it's not necessarily an unreasonable concern, right? I mean, a lot of us come from the data center world where potentially you did sign a contract with someone and then they'd raise that contract, and people have been bitten by this in the past. But I want to suggest to you that this is just not really a model that we've actually seen in the cloud world. We're a good decade or more into the public cloud revolution. This is not especially new at this point, and what we've seen over time as competition has increased, as the number of options have increased, that costs have gone steadily downward. This compute has been commoditized, it's being treated almost as a utility now, and there's just not the model or the historical precedent for cloud providers raising their prices to lock people in. If you can show me an example of it happening, I'll gladly change my tune there, but we simply haven't seen it. So you have to evaluate your risk and figure out what's really more important to you there. Are you going to take the, nebulous possibility that maybe the cloud provider will change the way they behave, or are you going to go with the very real likelihood that you're going to spend a lot of time building a system that's not providing you a lot of value? And in regards, by the way, to the idea that the cloud provider may deprecate a service, I need you to keep in mind that you need to pick a provider that you trust. So a lot of these services that I've been talking about are Amazon Web Services based. That's because I work with Amazon day in and day out, so I know them. That's why I keep bringing them up as examples. But I also trust them. They have a very good track record of not deprecating their services, and I definitely feel confidence in them. I've warned you there might be cartoons. Again, here's another one. I try to look at the lock-in question from the other perspective, right? You may have lock-in in the cloud, but you definitely have lock-in with technical debt and legacy hardware in your data center, all right? So it's just a matter of where you want to be constrained. So the economic aspect of serverless is one thing, but I think a lot of us in this room are technical. We want to know, how does serverless actually make my job easier as a technical person? And I think it absolutely does. A few days ago, knowing I was going to give this talk, I put out a question on Twitter asking for people that are actually using serverless in production to tell me why they love their stacks. I got a ton of great responses. You can go check this out. And I just pulled some of my favorite ones here to look at. So Roland says security, not having to worry about keeping his server up to date with every latest kernel patch. This is that fully managed question, right? You don't necessarily have to log in and do these patches because there are very good sysadmins at your cloud provider who will do this for you. It's very cool. Joel, who is a CTO of multiple startups over the years, I respect his opinion a lot, says fewer parts to build and maintain means faster and more consistent development velocity. All right? This is, again, is the idea that from a service-full perspective, you are not necessarily having to build all these things that don't differentiate you. You can focus on what does. Jeremy, the ability to handle massive traffic spikes. So he's talking about the scale advantages of serverless. Remember our college students back in Australia who built a system in just a few hours that could scale to 40 times the size of a massive government system that completely failed under load. This is what he's talking about. And he doesn't need to over-provision capacity to handle those workloads. So he's only paying for what he's using. Benjamin, hopefully you can see that, says to him, serverless is set it and forget it. Once the code is deployed, he doesn't have to worry about it ever again. Again, the advantage of working with a managed service. And then my favorite, and something that kind of sums up where I'm about to go with this talk, is from Ben Kehoe. He is a research scientist at iRobot, the makers of the Roomba, that robot vacuum you may have heard of. That, believe it or not, is a company that's heavily into serverless. And he says the number one reason they love their serverless stack, it lets us focus on what we do as a business. We don't have to solve technology problems before solving our business problems. And that leads me to the secret of this whole thing, which, as much as we as technology people may hate to hear it, going serverless is not primarily a technology change. It is an organizational change. It fundamentally changes the way you think about delivering value to your customers. And because of that, it's kind of hard sometimes for people to get their heads around. I do another talk with a colleague of mine named Jared Short called How to Win Coworkers and Influence Organizations for Serverless. And we do that talk because we've seen so many people that struggle with this, so much so that I've assigned personas to some of them. There's the legacy leader, the person who is invested in older technology like a data center and is just, really concerned about moving beyond that. You've got the antagonistic architect. This is the person who's asking you questions about lock-in. Can serverless really perform at scale the way it's promised to? The server-hugging sysadmin. Somebody who has been used to managing servers for so long, they can't imagine letting go of that control. That's almost a scary thing. And then the disrupted developer. Serverless can be hard on developers. It's a very different way of working. The traditional frameworks are out the window. The traditional architecture patterns are out the window. You really have to retrain and rethink. And most of those problems I mentioned aren't exactly technology problems. They're people problems. They're education and training problems. So there's a huge barrier here. And for that reason, I actually don't recommend serverless for every use case and in every situation. Here are some of the reasons I think you should avoid serverless technology. If you have a stable project today that is under budget, it's making your company money, maybe now is not the right time to refactor all that to serverless because there's going to be some cost up front. Maybe it's just not worth it. Serverless does provide some constraints. I didn't mention this before, but a Lambda function can only run for a maximum of 5 minutes. Some of you know that. That's great for a lot of things. For longer running jobs, well, that may simply not be useful for you. So you may still need a server. And then finally, if you're under a tight deadline, you've got a team that's really got other technologies that they're much more confident in, well, maybe you just don't have time to retrain. I'm really trying not to undersell the education gap that exists and the changes that are going to need to take place on your team in order to really make a serverless project successful. However, don't put your head in the sand here. For all the reasons that we spent most of this talk covering, serverless does provide you with some massive advantages. So I really hope you'll look into it when and how you can. Here's some ways I think you can get started. If you're on a smaller team, you've got perhaps a couple of team members that tend to be really gung-ho about the latest technology. Maybe they're already bugging you about using serverless. Maybe you're sitting here and you're that person. Try to find a feature that you've been struggling to implement using traditional services, something that you've spent a few weeks even trying to estimate under the old way of doing things, and see how quickly you can get that rolled out using services like Lambda and DynamoDB. Try to create something that solves a traditional pain point for you. Maybe you've got like a build server internally that's always filling up and running out of disk space, and everyone's just so frustrated with it. See if you can change that to use serverless technologies. And even if you can't be fully serverless, because a lot of us can't be fully serverless at this point, we've got workflows that don't make sense for that, perhaps never will. I want to encourage you to take the overall mantra of use servers less. Okay? You need to think of a server as a liability. It is providing you with maintenance overhead, technical debt, all sorts of things like that. So whenever you can remove those from your architecture, try and do that. Here's the bottom line. Build what differentiates you. I've been saying this in different ways throughout this talk. I want you to build things that provide unique value to your customers because that's really why you exist as a business, right? It's not to create some fantastic logging stack that all of your technical friends are going to be wowed by and that's going to make an amazing blog post for you someday. As fun as we may think that is, as engineers, that's not really why we're here. So where we can, we need to be pragmatic and leverage services that are better than what we could build. And to do that, of course, you'll have to partner with trusted vendors like Amazon in my case. There's others that are out there, but find someone that you trust. You can kind of stand on their shoulders and see higher than you could on your own. That's just smart business. And then take serverless seriously. I started by mentioning that serverless can be kind of a hypey buzzword thing, and it certainly can be, but this is a legitimate architectural movement. We're seeing this now in finance, banking companies, government, healthcare, kind of you name it. The companies that are on the forward edge of designing these systems are taking serverless seriously and are realizing the benefits, and I think you absolutely can too. And to prove that, I want to move back to the story we opened with, take us back to #censusfail and the Australian Census Bureau. So when we left them, they had just completely destroyed the confidence of the Australian public. They had gotten themselves in the news, which is the worst case scenario for any IT department. And only a little bit less than a year after that, they got tasked with another countrywide survey. In this case, it was for a referendum on same-sex marriage, something that was going to become extremely important in the history of Australia. And they knew they couldn't get this wrong. They had to restore the public trust. In order to do that, the ABS did what they called 400 Australia's worth of load testing against that system. That means they took the number of people that exist in Australia, they multiplied that number by 400, and that's the amount of load they threw at their system for this survey. What kind of architecture do you think they used to handle all of that? Well, we don't have to guess. they've actually made this architecture available. This is a diagram direct from the ABS. This is what they're doing. So what do we have here? Look over there toward the left. See where it says Amazon Poly and Connect? Those are managed services. They're Amazon services that handle text-to-speech and some call center stuff. That is the textbook definition of that serviceful programming model that we talked about. Amazon API Gateway, CloudFront, S3, all of them are usage-priced, fully managed services, no servers to be seen. And what do we have there at the right? Amazon DynamoDB and AWS Lambda. Event-driven, functional, stateless. My friends, this is a classic serverless architecture. They had a core team of 8 people that built this. And I don't know if you can see it down there at the bottom, but look how quickly they were able to get this running. Day 1 is when they were notified by the federal government that they had to do this. Day 8, they reached out to Amazon. Day 14 is when they actually got started building, and they got a complete working first version of the system out on day 20. That's 6 days to turn all of this around. Add in some more time, of course, for testing and compliance and all of that. They went live on day 50, and from what I understand, everything worked swimmingly. It was a complete success, and hopefully the Australian public is no longer hashtagging them with census fail. So that's a serverless success story I think we can all appreciate. And I want to encourage you that if the ABS can turn things around in this way, you can and I can as well. We can definitely find a place for serverless in our environments and start to realize some of those benefits. I would love to help you with that if I can. This is literally what I do for a living. So please reach out to me. You see my Twitter handle there at Forrest Brazeal. Would love to connect with you. You can also find me at forrestbrazeal.com where I try to write about serverless or on Trek 10's blog. I have a podcast there as well called Faz and Furious for Functions as a Service and try to talk in short, simple ways about functions as a service and serverless in hopefully ways that will be helpful if you're just trying to learn about that. So please try to take advantage of those resources or reach out to me, see if there's something I can do to help move you forward. And I would love to keep the conversation going.